Okay, I just want to take a few moments and talk a little bit about one- and two-tailed tests and how to recognize them in a problem, and then what the implications of those, of having a one- or two-tailed test are for working various problems. So first of all, how to recognize that it's a one- or two-tailed test. If the question said, is the population mean, or do we have enough evidence to conclude that the population mean is greater than 70, that's a one-tailed test. Our research hypothesis, or HO, is going to be that we're equal to 70, and we want to know if we conclude that it's greater than. So that's a one-tail upper. By contrast, if we said, I'm going to skip some space here, and you should too, we're going to, if I can get everything on one page, probably not, but I'll do as much as I can on one page. Is the population, that should have said up there, mean less than 70? Now we want to know if it's less than 70. So we're down here, but it's still one tail, but it's on the lower side of the distribution. That means that if we're talking about a z-test, that this would be plus z, and that would be a minus z, because we're some z standard deviations below the mean. And then and the last one is the population mean different or not equal to 70. So now it can be different in either direction. We still have the mu equal 70 here, but we could be not equal to 70 because we were low, or not equal to 70 because we were high. Okay, so some of the implications of that. When you're doing the critical value approach, here we're going to say reject HO if z-test is greater than some point. If we had alpha 05 on all of these, this is a one-tailed, so that's 1.645. And this one, we still have one tail, so we're going to reject HO if z-test, but since we're on the lower side here, it's less than minus 1.645. On the bottom one here, now it's a two-tailed test, and we're going to reject HO if z-test, it's a different value, greater than 1.96. If you look on the table of z-values, you'll see for a two-tailed test and 05 that it's 1.96 or less than minus 1.96. So for the critical value approach, your decision rules depend on whether you have a one- or two-tailed test, and then if you have a one-tailed test, whether or not it's upper or lower. Is the population mean greater than 70? So HO would have been HR would have been mu greater than 70, one-tailed upper. Notice in the HR it's got a greater than right there. You're also going to have a greater than right there. In this one, you would have had HR mu less than 70. So when you get down here, you're going to have less than, and if you have less than, it's always going to be less than a minus because you're on this side of the distribution. In some other instances, you just want to know if the population mean differs from 70, and so you reject if you get too high, above 1.96, or too low. And the HR and this one is mu not equal to 70. Now the other hypothesis testing thing has to do with p-values. Here's the basic point of p-value. You know, when you do it for a one-tailed test, you're just computing the area and the tail. So, you know, the p-value would be, you know, might be here. Whatever this, our hypothesized mean, it might be here, or it might be that it's some low number out here. It's based on whatever we calculated for x bar, the difference between x bar and the hypothesized mean. So it's just the probability in the tail. Well, it's the same thing over here. There's just going to be, when you compute an x bar, how much area is below there, or if you computed one here below there. It's a probability. So let's say alpha is 0.05. The decision rule is going to be reject HO if p-value is less than 0.05. It's a probability for this one, and also for the two-tailed test. The difference in the two-tailed test is when you calculate p-value, you'll calculate area in both tails and sum them together. But once you get the p-value, it's always reject HO if the p-value is less than whatever your cutoff or alpha level is, in this case 0.05. So as I've heard the saying, it's if the p-value is low, the null hypothesis must go. So if it's low, you reject HO, which means that you have, I guess if you want to talk about it, you've supported whatever your research hypothesis was.